The idea of artificial beings is not new. Ancient myths told stories of mechanical men and thinking statues. These tales showed a long human fascination with creating life. For centuries, these were just dreams and stories. Technology was not ready to make them real. The journey from imagination to actual machines was long. It required many small steps and big ideas. People started by making simple, automated devices. These were often for entertainment or basic tasks. They were not truly intelligent, but they were a start. The 20th century brought huge changes. The birth of computers was a key moment. Scientists began to seriously explore artificial intelligence, or AI. They asked if machines could truly think. Early AI research focused on logic and problem-solving. Robots at this stage were mostly experimental. They were confined to laboratories and research institutions. These early machines were often bulky and limited in function. They could perform pre-programmed tasks but lacked real understanding or flexibility. The dream of intelligent robots was still far off. Early robots were more about automation than intelligence. They followed precise instructions. Think of robotic arms in factories doing the same task over and over. This was a big step for industry, but not true AI. The challenge was to make robots that could sense their environment. They needed to make decisions and learn from experience. This required merging robotics with the growing field of AI. It was a difficult task. Progress was slow but steady. Researchers imagined a future where robots could do much more. The shift from purely mechanical automatons to machines with even basic AI was gradual. It involved breakthroughs in computer science. It also needed advances in engineering and materials. The first AI robots were simple by today's standards. They might navigate a room or identify simple objects. However, these early experiments laid the essential groundwork. They proved that machines could perform tasks that once required human thought. This set the stage for the more advanced robots we see emerging today. The mid-20th century saw the first programmable robots. George Devol and Joseph Engelberger created Unimate. Unimate was the first industrial robot. It started working at a General Motors plant in 1961. Its job was to lift and stack hot pieces of metal. This was a dangerous and unpleasant task for humans. Unimate showed that robots could be practical tools in industry. It marked a significant milestone in the history of robotics. This robot did not think for itself. It followed instructions carefully. Further developments focused on giving robots more senses. Researchers worked on machine vision. They wanted robots to see and understand their surroundings. Early vision systems were very basic. They could recognize simple shapes or patterns. Locomotion was another big challenge. Early robots were often stationary or moved on fixed tracks. Creating robots that could walk or navigate complex spaces was a major hurdle. Each small success built confidence and fueled more research. The goal was to make robots more autonomous and versatile. Shaky, the robot developed at Stanford Research Institute in the late 1960s, was a landmark. Shaky was the first mobile robot that could reason about its own actions. It could perceive its environment using a camera and touch sensors. It could plan and execute tasks that involved navigating obstacles, while slow and deliberate, Shaky demonstrated integrated AI. It combined perception, reasoning, and action. This was a huge leap from fixed industrial arms. Shaky truly was an experimental machine paving the way for future AI robots. These early milestones were crucial. They moved robotics from simple automation to the edge of artificial intelligence. They showed that machines could do more than just repeat tasks. They could sense, plan, and act in limited ways. The lessons learned from Unimate, Shaky, and other early projects were invaluable. They highlighted the immense challenges ahead, but they also provided a glimpse of the transformative potential of AI robots. The journey was just beginning. These pioneers laid the foundation for the sophisticated machines we see today. Industries, especially manufacturing, were quick to see the benefits of robots. AI has supercharged these industrial robots. Modern factories now use robots for many tasks. They perform welding, painting, assembly, and packaging. These robots are faster, more precise, and more consistent than human workers. They can work 24 hours a day without needing breaks. This increases productivity and efficiency. It also lowers production costs for many companies. The impact on manufacturing has been enormous. AI-powered robots in factories are not just following simple programs anymore. They use computer vision to inspect products for defects. They can identify tiny flaws that a human eye might miss. They learn from data to improve their performance over time. Some robots can even work safely alongside humans. These are called cobots or collaborative robots. They are designed to be aware of human presence. This allows for more flexible manufacturing setups. Humans and robots can share tasks and workspaces. The automotive industry is a prime example of robotic adoption. Car factories are filled with robotic arms. These arms lift heavy parts and perform precise welding. They assemble components with incredible accuracy. The electronics industry also relies heavily on robots. They handle tiny components and assemble complex circuit boards. These tasks require a level of precision that is difficult for humans to maintain consistently. AI helps these robots adapt to new product designs quickly. It reduces the need for extensive reprogramming. Beyond assembly, AI robots manage logistics within factories. Autonomous mobile robots, or AMRs, transport materials and components. They navigate busy factory floors using sensors and AI. They deliver parts to assembly lines exactly when needed. This optimizes the flow of materials and reduces downtime. The use of AI robots in industry is constantly expanding. They are becoming smarter, more adaptable, and more integrated into all aspects of production. This trend is set to continue, reshaping the nature of industrial work. A new type of robot is emerging. These are social robots designed to interact with humans. Sophia, developed by Hanson Robotics, is a well-known example. Sophia is a humanoid robot. This means she's designed to look like a human. She has a face that can show expressions. She can make eye contact and engage in conversations. Sophia uses natural language processing, or NLP, to understand spoken language. She also uses it to generate her own responses. This makes her interactions feel more natural. Sophia's abilities are a result of advanced AI. Her AI algorithms analyze conversations. They try to understand context and intent. Computer vision helps Sophia recognize faces. She can identify people she has met before. This allows for more personalized interactions. While Sophia's intelligence is still a subject of debate, she represents a significant step. She shows the potential for robots to become companions or assistants. She has even been granted citizenship in Saudi Arabia, sparking much discussion. The goal of social robots like Sophia is not just to perform tasks, it is to engage with people on a social and emotional level. They are being explored for various roles. These include education, healthcare, and customer service. Imagine a robot tutor that can adapt to a student's learning style, or a robot companion for elderly individuals to combat loneliness. These are the kinds of applications being considered. The ability to process language and understand human cues is vital for these roles. Developing truly effective social robots is very complex. Human interaction is nuanced and subtle. AI needs to understand not just words, but also tone, body language, and emotion. While current social robots are still learning, they are improving rapidly. They are gathering vast amounts of data from their interactions. This data is used to train their AI models. As NLP and computer vision technologies advance, social robots will become more capable. They could become a common feature in our lives, helping and interacting with us daily. Section 5. Masters of Movement, Boston Dynamics and Tesla's Optimus redefining agility. Robots are also becoming much more mobile and physically capable. Boston Dynamics is famous for its advanced robots. Their robots, like Atlas and Spot, show incredible agility. Atlas is a humanoid robot that can run, jump, and even do backflips. Spot is a four-legged robot that looks like a dog. It can navigate very difficult terrain. These robots use sophisticated sensors and AI. They can maintain balance and adapt their movements in real time. This is a huge leap from earlier robots that were clumsy or slow. Boston Dynamics robots use a combination of technologies. Advanced locomotion algorithms control their movements. These algorithms are inspired by how animals and humans move. Computer vision allows them to see and map their environment. They can identify obstacles and find safe paths. Their physical dexterity allows them to perform tasks in challenging settings. Spot is already being used for inspections in construction sites and industrial plants. it can go places that are dangerous or difficult for humans. Tesla is another company pushing the boundaries with its Optimus robot. Optimus, also known as Tesla Bot, is a humanoid robot. Tesla's goal is for Optimus to perform unsafe, repetitive, or boring tasks. Elon Musk has stated that Optimus could eventually be more significant than Tesla's car business. The robot leverages Tesla's AI expertise from its self-driving car program. This includes advanced computer vision and neural network processing. The aim is for Optimus to learn and adapt to various tasks in human environments. The development of robots like Atlas and Optimus is very important. It shows that robots are becoming physically adept. They are no longer limited to controlled factory environments. They can potentially operate in the messy, unpredictable human world. Their advanced locomotion and manipulation skills open up new possibilities. They could be used in disaster relief, logistics, and even in homes. As these robots become more capable and less expensive, their impact will grow. They are redefining what robots can do physically. Section 6, Beyond the Assembly Line, AI robots entering our daily routines. AI robots are slowly moving beyond factories and laboratories. They are beginning to find roles in our everyday lives. We are seeing them in homes, hospitals, and service industries. For example, robotic vacuum cleaners are now common in many households. These small robots use sensors and AI to navigate rooms. They clean floors autonomously. While simple, they represent an early form of domestic robotics. More advanced home robots are being developed. They aim to help with chores, security, and companionship. In the service sector, robots are appearing in customer-facing roles. Some restaurants use robots to greet customers, take orders, or deliver food. Hotels are experimenting with robotic concierges or luggage handlers. In retail, robots might help with stock management or guide shoppers. These robots rely on natural language processing to interact with people. They use computer vision to navigate crowded spaces. Their presence is still novel, but it points to future trends. As they become more sophisticated, their roles will expand. Healthcare is another area where AI robots are making inroads. Surgical robots assist surgeons in performing complex operations. They offer greater precision and control. Robots are also used for delivering medication or supplies within hospitals. They can help with patient monitoring or provide assistance to elderly patients. For instance, robotic exoskeletons can help people with mobility issues to walk again. AI helps these robots understand patient needs and adapt their actions accordingly. This can improve patient care and outcomes. The integration of AI robots into daily life is still in its early stages. There are many challenges to overcome. Robots need to be safe, reliable, and easy to use. They also need to be affordable for widespread adoption. However, the progress is undeniable. From cleaning our floors to assisting in surgery, AI robots are becoming more prevalent. They are gradually transforming how we live, work, and interact. The line between specialized industrial machines and everyday tools is blurring. Section 7. The horizon beckons cognitive leaps and physical adaptability in future robots. Looking ahead, AI robots are poised for remarkable advancements in the next 2 to 3 decades. We can expect significant leaps in their cognitive abilities. Today's AI, while powerful, often struggles with true understanding and common sense reasoning. Future robots will likely possess more sophisticated AI. This will allow them to learn more quickly and adapt to new situations more effectively. They might be able to solve complex problems creatively. They could even understand and respond to human emotions with greater accuracy. This enhanced cognition will make them more versatile partners. Physical adaptability will also improve dramatically. Robots will likely come in many different forms, tailored to specific tasks. We might see bio-inspired robots that mimic the agility of animals. Some could be soft robots made from flexible materials. This would allow them to operate more safely around humans and in delicate environments. Nanorobots, microscopic machines, could perform tasks at a cellular level. Think of medical nanorobots repairing tissues or fighting diseases from within the body. The physical design of robots will become incredibly diverse. Future robots will need to be highly adaptable. They will operate in dynamic and unpredictable human environments. This requires more than just pre-programmed instructions. They will need to learn continuously from their experiences. This means improving their models of the world and their own capabilities. Machine learning techniques, especially reinforcement learning, will be crucial. Robots will learn by trial and error, much like humans do. This will enable them to master new skills and perform a wider range of tasks without explicit reprogramming for every scenario. The ability to collaborate will also be a key feature. Robots will not just work independently, they will work together in teams, coordinating their actions. They will also collaborate more seamlessly with humans. This human-robot interaction will become more natural and intuitive. Robots might understand unspoken cues or anticipate human needs. This level of cognitive and physical adaptability will unlock new applications. It will make robots indispensable in many areas of life and work, fundamentally changing our society. Section 8. Smart Cities and Global Networks. Robots as an integral part of future infrastructure. AI robots are expected to play a crucial role in the development of smart cities. Smart cities use technology to improve the quality of life for citizens. They aim to make urban environments more efficient and sustainable. Robots will be a key component of this technological infrastructure. Imagine autonomous vehicles for public transport and deliveries. These are essentially robots on wheels. They will reduce traffic congestion and pollution. They will make transportation safer and more accessible for everyone. Robots will also manage city maintenance and services. Small, specialized robots could inspect and repair infrastructure. They might check bridges, tunnels, and pipelines. They could clean streets or manage waste collection autonomously. Drones, which are flying robots, will monitor traffic flow. They can assist in emergency response situations. They might deliver medical supplies quickly in a crisis. These robotic systems will be interconnected. They will share data and coordinate their activities to optimize city operations. The concept of a global AI grid is also emerging. This refers to a network of interconnected AI systems and robots. This grid could manage resources on a larger scale. It might optimize energy distribution or monitor environmental conditions globally. Robots connected to this grid could share knowledge and learn from each other. A robot in one city might learn a new skill. It could then share this learning with other robots around the world. This would accelerate the development and deployment of robotic capabilities. Integrating robots into smart city infrastructure and global networks presents challenges. Cybersecurity will be a major concern. We need to ensure these systems are safe from hacking. Data privacy is another important issue. Robots will collect vast amounts of data about our cities and our lives. We need clear rules about how this data is used and protected. Despite these challenges, the potential benefits are immense. AI robots could help create smarter, greener, and more livable cities for the future. Section 9. The Human Element. Navigating ethical terrains and philosophical questions with AI robots. As AI robots become more capable and integrated into our lives, they raise profound ethical questions. One major concern is job displacement. If robots can perform many human tasks better and cheaper, what will happen to human workers? We need to consider how society will adapt to this massive shift. This might involve new economic models. Perhaps concepts like universal basic income will be necessary. We need to think about retraining programs and the future of work itself. This is a central theme in my book, Rise of the Robots. Another set of ethical questions revolves around responsibility and accountability. If an AI robot makes a mistake and causes harm, who is responsible? Is it the programmer, the manufacturer, the owner, or the robot itself? As robots become more autonomous, these questions become more complex. We need to develop legal and ethical frameworks to address these issues. We also need to consider the potential for misuse of AI robots. Autonomous weapons, for example, pose a serious threat to global security. Clear guidelines and regulations are urgently needed. Philosophical questions also arise. What does it mean to be human if machines can replicate many of our abilities? If robots develop consciousness or sentience, what rights should they have? These are no longer just science fiction scenarios. As AI advances, we may need to confront these questions directly. The development of sophisticated social robots like Sophia already blurs some lines. Our relationship with these intelligent machines will force us to re-examine our own place in the world. It will make us think about what defines humanity. Ultimately, the integration of AI robots into society requires careful thought and planning. We need a broad public discussion about the kind of future we want to create. This discussion should involve technologists, policymakers, ethicists, and the general public. The potential benefits of AI robots are enormous. They can improve our lives in countless ways, but we must also be mindful of the risks and challenges. Navigating this new era will require wisdom, foresight, and a commitment to ensuring that technology serves humanity's best interests. The future is not predetermined. We have a role in shaping it.